Hi, good evening, everyone. Today we will go ahead and we will solve this question. So you have to consider this function and you have to talk and tell whether this function is differentiable or continuous at x equal to 1. As you can clearly see, this function is getting broken at x equal to 1, right? So for it to be continuous, what would I require? I would require that the left-hand side limit should be equal to the right-hand side limit and it should be equal to the value of the function. Okay, let us try that function now. So limit x tends to 1 minus fx. When I approach from 1 minus, that means less than 1, which part of the function will I take? I will take this part. So I will take 1 minus limit x 1 minus, and what part of the function will I take? I will take 1 minus x squared under root. In this I will put x equal to 1. So I will get 1 minus 1 under root 1 minus 0. So I will get the answer as 1. So when I am approaching this from the left hand side, I am getting the answer as 1. Now let's approach this from the right hand side. So limit x tends to 1 plus fx. This will be 1 plus log. So this is 1 plus log 1 by x, right? So 1 plus log 1 upon 1. So 1 plus log 1. So that will only give me the answer as 1. So the left hand side limit is equal to the right hand side limit. And of course, when I have the function at 1, I will get this only, right? Because at 1 also, I just have this function. When x is equal to 1, I just have this function. So which means that limit x tends to 1 minus fx is equal to limit x tends to 1 plus fx is equal to when you put the function 1. In which case will I put the function as 1? Only here, because x equal to 1 is included here. So 1 minus 1 under root is just 1, right? So it is equal to the value of the function at 1. Therefore, function is continuous at x equal to 1. So we have proved that the function is in fact continuous at x equal to 1. So actually what you can go ahead and do, you can actually start looking from here and you can just go ahead and you can just cancel out this option that it is neither continuous nor differentiable. Now let's talk about the derivative of the function. So I have to check limit x tends to 1 minus. So what was my function when I was approaching it from 1 minus? Well, my function was this. 1 minus x squared. So my function was 1 minus x squared under root. So if I differentiate this function, what will I get? Minus 1 by 2 under root 1 minus x squared, right? So into, so you know, right? So whenever you have to go ahead and differentiate the function, you have to apply chain rule. So when I talk about differentiation of root x, it is 1 by 2 root x. This is what I did. And then you have to differentiate what comes inside. So its differentiation will be minus 2x. So this is going to be 2x upon 2 under root 1 minus x squared. So it is going to be x upon 1 minus x squared under root. This is going to be your derivative. Now you have to evaluate this derivative at x equal to 1. So at x equal to 1, this is going to be 1 upon 1 minus 1 square under root. This is going to be 1 by 0. So it will be infinity. Now let's go ahead and look at the second part of my function. So my function is given as 1 plus log 1 by x. So the derivative of this function will be, what is the derivative of log 1 by x? Log ka derivative has to be 1 upon 1 by x. And what is the derivative of 1 by x? Minus 1 by x square. Isn't it? So if I start solving this, I will get x by 1 into minus 1 by x squared. So it will be minus 1 by x. Evaluate this derivative at x equal to 1. So limit. So this is when I'm going from the right hand side, right? When I took x as 1 plus, this was my function. So the derivative was this. So at x equal to 1, what will I get? I will get the answer as minus 1 by 1, which is minus 1. So the left hand side and the right hand side are not equal. They are different. So which means the function is not differentiable, but it is continuous. So what have we got? We have got that the function is continuous, but it is not differentiable at x equal to 1. So the answer to this question is B. Now, I'm giving you a similar question to practice. Please do it yourself. So your function is, let's say, minus x minus 1. You have to, and you're given the same 4 options. 1, continuous and differentiable at x equal to 1. B, not continuous and not differentiable at x equal to 1. C, continuous but not differentiable at x equal to 1. And D, not continuous but differentiable at x equal to 1. So these are the 4 options. You have to look into it and tell me what your correct answer would be. Okay, thank you.